Come on. There we go. There we go. Okay. Example 6. So the 500 Newton force is downward, right? What's the angle that the 500 makes with the 12-meter hypotenuse? What's the angle that 500 newtons makes with the 12-meter hypotenuse? Anybody know?
60.
I know 60, Golnas.
Divide from 90. I can't explain.
Can't explain?
Like that one is 90, that one 30, and that one
Ah,
is 60.
good. So they add to 180, right?
Yeah.
So this is 90, this is 30, and this is 60, right? Because all the angles in the triangle add up to 180. So when our 500 Newton bookcase slides down this staircase, the is
An angle? Oh, it's
60.
60 degrees. Good. So theta is 60 degrees.
Oh, crap.
Displacement is 12 meters. Does that make sense? Does that make sense, guys?
Yeah.
Yeah. So work equals force times displacement times the cosine theta. Work equals 500 times 12 times cosine 60. What does that equal? 3,000.
Okay, that's what I said. I did a lot less work.
Yeah. Okay. What'd you do, Kevin?
6 times 5.
Why'd you do 6 times 5?
Is that the distance down?
How do you know it's the distance down?
The 3069 you triangle.
Ah, so this is.
And plus you said it.
I did, didn't I? Okay. So in the second one, Kevin's saying all he did for part A was he just looked at part B and said, well, it's 6 meters down. Right? So how much of the displacement is parallel to the force? 6 meters. So if the bookcase falls the other way, we just do that, don't we? Right? What's the force? 500. What's the displacement? 6. Right? Because now instead of sliding down, we're going this way, aren't we? So what do we get? 3,000. Never heard it referred that way before, but that's good. Surprised me every day, Tim. All right. So both of those are 3,000, right? So what this further shows us is that work is path independent. Okay? I'll write that down. Work is path independent. Okay? Work is path independent. So that means, Julian, that means that the work done does not depend on the path, we'd say. Okay? As long as we start and end at the same spot. Okay? And when I say same spot, I don't mean like here both times. I mean the displacement that's parallel to in the same direction as the force is the same. Okay, does that make sense, guys?
Yep.
Yeah. So if this 500 Newton bookcase flies all around and lands right there, guess how much work was done by gravity? 3,000 joules. It doesn't matter how long that path was. Okay? As long as it goes the same distance parallel to the force, the same amount of work was done. Does that make sense? That's why spiral staircases, even though they're cool, they don't cut off any work. Just go to the same height. That's why ladders and stairs, you do the same amount of work.
Not if you slide.
Not if you want. You do. Displacement and force, same height.
You're not using it.
All right. Example 7. A 35-kilogram child pulls a 250 Newton wagon full of rocks with 150 Newton force. The wagon's handle makes an angle of 20 degrees with the ground. How much work is done by the child if he moves the wagon 8 meters? So you guys are probably saying, why is a child pulling a wagon with rocks? What kids do, right?
I don't know.
No one else had a rock collection they kept in the wagon?
No.
Yeah, I just figured that. So,
Why does he have a balloon?
Because.
He's pulling a wagon of rocks. Why would he have a balloon? What kid pulls a rock?
And he has a cool comb over.
Oh, he's got-
It's his birthday, man. He got the rocks for his birthday gift.
What about the wagon?
Yeah.
The wagon he got last year.
So he just now was able to find those rocks that
He
just
was.
magically appeared?
He was.
Alright.
Maybe the order was messed up there. All right. So there's the kid. He's pulling the wagon. All right. He's got a balloon. Show he's a kid. All right. What do we know in this case? Yes.
If it's his birthday, where's his hat? Okay, thank you.
Okay, there you go. Okay. So, birthday party. Maths. Maths of what?
35.
35. Of who?
Children.
The child, right? Oops, 35 kilograms. What else we know?
Force.
Force of what?
250.
Is that the wagon, the force of gravity in the wagon, or is it the force he pulls the wagon with? Okay. So the force of gravity in the wagon down here is 250 newtons, right? What other force do we know?
150.
So that force is 150 newtons, right? What else?
Degree.
What?
Degrees.
Oh, degrees.
Yeah.
Thank you. How much degrees?
20.
20. Where do they go?
Wow. You got somewhere you can do the ankle mark?
Ah, good. 20 degrees goes right there. What else?
8 meters.
8 meters. So the 8 meters is displacement that way, right? So we want to figure out the work done. Now, in typical Mr. Branch fashion, I gave you way more information than what you need, didn't I?
Probably.
Because there's only 3 unknowns in the work equation, right? I gave you 1, 2, 3, 4, 5 numbers. So which ones do you need?
I'm guessing the angle.
Okay, we probably need the angle.
The displacement.
The displacement.
The force. Yeah. Then 200.
Which force?
250.
250?
Yeah.
Sergio says the one he pulls with. Which one does he pull with, Sergio?
35.
No, 150, Sergio.
Yeah.
So, which force do we need? The 150 or the 250?
150. No.
Just throw a dart at one of them. Whichever one you hit, that's the one.
That's not it.
Why not?
That's not right.
You add them together.
Nope.
Subtract.
We don't throw a dart at it.
If you hit the right
Okay.
one, it is.
We're worried about the work done by that child, right?
You won't even need that.
Who applies the 250 Newton force?
Gravity.
Gravity.
The 150.
The Earth applies the 250, right? So am I worried about the work done by gravity in this case?
Yeah.
No.
No. It asks for the work done by the boy, the child, right? So which one is the work done by the child? Which one is the force applied by the child?
150.
150.
150. So which force do we use?
150.
150.
If I would have thrown a
I
dart, I would
say
have
that
hit
enough
250,
times.
missed and hit 150, so.
I know you were math. Okay. So, how can I find the work done? Multiply with cosine 20, right? So, work equals force, displacement, cosine theta. Plug in and multiply. So, 150 times 8 times cosine 20. So what do we get?
Wait, would it be 70?
No, it would not be 70. So you're getting in the habit of just subtracting everything from 90, aren't you? Okay. Well, the displacement is horizontal, right? So the displacement is this line. So the 20 they already gave us. That's the angle between force and displacement. Okay? If the kid was pulling it up a hill, and I said the height the kid gained was 8 meters, then we would subtract that from 20. Okay, does that make sense?
Yeah.
Okay. So how much work is done?
1,127.
1,127.
0.62.
Does that make sense? Does that make sense, guys?
Yep.
Yeah, are there any questions?
No questions.
I'd like you guys now to take a look at example 9 and example 10. Oh, 8? Oh, thank you. Example 8, 9, and 10.
Okay, I was kind of referring